Hello, welcome everyone. In this question it says 63 kilogram astronaut is on a spacewalk when the tether line to the shuttle breaks. The astronaut is able to throw spare 10 kilogram oxygen tank in a direction away the shuttle at the speed of 12 meters per second, propelling the astronaut back to shuttle. Assuming the astronaut starts from rest, so initial velocity of astronaut rest. With respect to the shuttle, find the astronaut final speed with respect to the shuttle after tank is thrown. So if the astronaut initially at rest, so oxygen tank also at rest because it's with astronaut. This is the conservation of momentum. So m1 times v1 initial plus m2 times v2 initial, that will be equal m1 times v1 final plus m2 times v2 final. And if the astronaut at the initial rest, oxygen tank and the astronaut must be at rest. So both velocity of the astronaut and the oxygen tanks will be 0. So due to this, left side of the equation gonna be 0. And then if we send this side to the other side, so m1 times v1 final must be equal negative m2 times v2 final. And m1, let's say it is the astronaut, so it will be 63 kilogram times v1 final, we don't know, which is the question, minus m2, which is the mass of the oxygen tank, which is 10 kilogram, times velocity of the oxygen tank is 12 meters per second. So v1 final, it means the final velocity of the astronaut will be 1.9 meter per second to the shuttle. Thanks for listening.